I want to have a look at some numbers in some other bases. So we're familiar with the decimal number system, which is a base 10 number system. And being a base 10 number system, it uses the digits 0, 1, 2, 3, all the way through to 9. And the way it uses those digits is in a place value system. And the place value system you'd be familiar with starts off with our units as our first place value, which is our ones. And then we have our tens. And then we have our hundreds. And then we have our thousands. And so on. And every time we're growing by a power of 10. So this is just 10. The hundreds is 10 lots of 10. And I can write that in index form as 10 squared. Thousands is 10 times 10 times 10, which is 10 cubed in index form. And so when we write the number 14, for instance, so the number 14 is 1 lot of 10 plus 4 lots of 1. Now, not all number systems have to be base 10. Base 10 is convenient for us. We've got 10 fingers, perhaps that's where it came about. And we like to group things in tens. But computers sort of talk a little bit differently. And what they do is they work in a base 2 system. And a base 2 system simply has a 0 and a 1 as its digits. No other digits. So you'll never see a digit for 2, 3, up to 9, etc. being used in base 2. And that's because computers work on an on-off basis. If it's doing something, it's saying is it on or if it's off. And you might be familiar. And if you look at devices, you might see this symbol is often the on-off switch symbol, a 0 and a 1. And so with base 2, the place value works in much the same way as the base 10 place value, in that you have a units, which are our ones, but then we're not grouping in tens anymore, we have our twos as our second place value. And then what we have after that is our fours. And after our 4s, we have our 8s. And after our 8s, we have our 16s. And just like in base 10, where we're increasing by lots of 10, we're increasing by lots of 2. 4 being 2 times 2, which is 2 squared. 8 being 2 times 2 times 2, or 2 cubed. And 16 being 2 to the power of 4 in index form. So if in this system I write the number 1, 1, then what I'm saying here is I have 1 lot of 2 plus 1 lot of 1. So actually that's 3 in base 10. So my 1, 1 in base 2 is actually 3 in base 10. So I just have to interpret from a place value chart. So if I write the number 1, 0, 1, then what I have there is I have a 1, 4, 1 lot of 4, and then I have no lots of 2, and then I have 1 lot of 1. So I have the number 4 plus 1, which is 5 in base 10. So that's the number 1, 0, 1 in base 2, is actually the number 5 in base 10. Okay, so now let's have a look at another base. Let's have a look at base 5. So we're thinking, what if we only have one hand? What sort of arithmetic might we have developed if we only have one hand? So with base 5, we're talking about using the digits 0, 1, 2, 3, and 4. Only those digits can be used in base 5. And so our place value in base 5 is going to start off in the same idea. We have our units, which are our ones, and we're going to group in 5. So we're going to have 5s. And then after our 5s, we'll have 5 lots of 5, which is 25. And if we, next group of 5 is 5 lots of this, which is 125. If we go 5 lots again, we get 625. So this is how we group in base 5. So this is 5 squared, this is 5 to the power of 3, this is 5 to the power of 4. I'll leave it to you to work out what the next place value would be above that. So if I want to take a number that's written in base 5 and convert it back to base 10, it's not that hard to do. So if I take the number 2, 3, 1 in base 5, then I look at my place value and I see I've got 2 25s, I've got 3 lots of 5, and I've got a 1. And so that's going to give me 50, 66 in base 10. And so that will hold. So if we just do another quick example, I'll do a bigger one. So if I go 4, 0, 1, 0, 2, then I've got 4 lots of 625, no 125s, 1 lot of 25, plus 2 lots of 1. And so when I add that up, if I do this, I get 2,525 plus another 2 gives me 2,500 and, not 50, 2,527. This is 2,527 down here in base 10. Okay, so that's how we move from base 5 into base 10. What about if we want to go the other way? What if we want to write, let's pick an easy number, 32 in base 10 in base 5. Now we don't normally write the 10 here, I'm just doing it to help distinguish in this example. So 32 base 10 in base 5. Well, I look back at my place value and I can see I've got to look at the 5s, lots of 5s. So I've got to break this 32 up into these numbers somehow. So I've got to think 32, well there's a 25 in there, and there's another 5 in there, and there's 2 1s in there. So 32 in base 5 is a 125, 1 5, and 2 1s. So if we'd only ever had one hand, perhaps rather than writing 32, we would write 112 as our base 5 number. So I'll do another one. I'll do 423. So 423 is base 10. I want to write this now in base 5. Okay, so we're getting a bigger number here. So obviously lots of 25 in there, but I can't go any more than 4 lots of 25. So I can't go more than 100 in this column. So I'm going to come over this column, 125. So I need to see how many 125s in that. So 423. Now 3 lots of 125, that's 375. So I know then that I need another 1 lot of 25, and that takes it up to 400. So I'm adding up as I go. I'm going, that's 375 plus 25 is 400. I can get my 20 by saying 4 lots of 5. So now up to 375, 420, and I've got 3 lots of 1. And so in base 5, this number is 3143 in base 5.